Okay, so yesterday we got through most of part one of kind of some review stuff. So we'll finish part one and then we'll take a look at part two. All right, so I think we did this part, right? Terms? Okay. So
yeah, well, I think we're at like defining what a like term is and thing.
Yeah. So those are all terms because they're separated by a plus and a minus sign. If I wrote something like this, are there any plus or minus signs in 7xy? No. Then that's just one big term. You don't, it's kind of think of a plus or a minus sign as like a break. Once you see that, okay, now you're on to a new term. That's, even if I did something like this, ABC, that's one term. Plus 2. Now there's a plus sign, the 2 is another term. And when you have a number by itself, what kind of term do we call that? It's not a variable, because variable means things can change.
That can't change.
So what's something that never changes? It's always a constant. So 18, 2, 7, that's a constant term. Or you can just call it a constant. Same thing. All right, so I think this is where we left off, like terms. Anyone think they could give me an example of like terms? So you give me a term, and then just give me another term. And I'll tell you, we'll see if they're like terms. Yeah?
7x plus 7.
So 7x and what?
7.
7. Okay.
You guys, you don't have to write that for like terms. That's just an example. We'll give you the definition in a second.
Anybody give me some comments on that? Do you think those are like terms? Do you think they're not like terms? And then how come? Yeah?
Those aren't like terms because one has a variable and one's a constant.
Yeah, they have to look the same. They have to have the same letters. Okay, that's the key.
So Mary said one has a variable and one doesn't. So we could just do this. We could just do that.
No.
Why no, Ellie?
Because it's not, you can't just put a y there. Like, it's not part of the equation.
Jake, what would I have to put here for a letter to make it a like term? To make it like this.
X.
X, right? So it'd have to be 7x. Do the numbers have to be the same for it to be a like term? Catherine, you're shaking your head no. So give me another example of a like term. Give me a pair of like terms. 5x, okay, and 5x and 6x.
Yeah.
Right.
So let's make it a little smaller so you guys can see this. All right, so, I guess I have to write this in. So, like terms.
Oh, we have a mistake.
Oh yeah, so we get it right there. It's a number.
Oh, I should say with.
Okay, got it. A number with. Oh my god. Oops.
So just add in when it says a number constant. After that, we're going to put in with.
So it's a number with the same variable, and if the variable has an exponent, that has to be the same as well. So somebody, I think we said 5x.
And Catherine said 5x and 6x.
And 6x. Okay. Can anyone give me another pair? Let's use other letters. Yeah.
14a plus 16a.
Yep. So 14a, 16a. All right. How about if I gave you 3xy? Somebody give me a like term for 3xy. Yep.
3xy.
Okay, yep, you could do 3xy. Does the number have to be the same? I think Mr. Roy already said that. No, but those are definitely like terms. How about if I did 2x squared
You read my mind mistake.
y, and I'm going to give you the other one. I want you to tell me if they're like terms. 4yx squared. So look at the definition. You might have a number in front, and it has to have the same variables. And if those variables have exponents, they have to be the same as well. 2x squared y, 4yx squared. Those like terms.
At this time, all seniors with your instructors. Please head.
Are they doing like the?
A number.
Yeah, Mary, what were you gonna say?
They are because they have the same variable and the same exponents.
Exactly. Did everybody hear what she said? Those are like terms. They have the same variables, x and x. There's an exponent of a 2 on the x on the one on the left. There's an exponent of a 2 on the one on the right. And then there's a y and a y. So notice the definition of like terms doesn't say they have to be in the same order. Okay? So what about if I did 2ab and 5ba? Are those like terms? Yeah. So I think we're getting the hang of it. Okay? Those are like terms. Generally though, if they're like terms, we like to put them in the same order, but those are all examples of like terms. All right, non-like terms. Well, basically anything that doesn't fit that definition. One term and the other term have different letters or a different exponent. So under non-like terms, a number, a constant. Should I take out the?
Yeah.
A number, a constant with a different variable or different exponents.
And again, like terms aren't always going to have, you won't always have a variable with an exponent attached. Sometimes you do, sometimes that's why we wrote if applicable. You may have it, you may not.
All right, so anyone think they can give me an example of non-like terms? Things that if we wanted to add them, we couldn't do it. Okay, all of these we could. 5x plus 6x, 11x. 3xy plus another 3xy, 6xy. Give me something that I couldn't add up or subtract. I'm still on the names. Yeah, Chris.
3 and 7y.
3 and 7y. Perfect. If you wanted to add or subtract 3 and 7y, you can't do it. Okay, I'm not sure if we wrote that down, but like terms is what you have to add or subtract. Someone give me another example of non-like terms, yeah?
X plus 69.
X plus 69. So again, we can't add those or subtract them. How about 2x and 4x squared? Are those like terms? Why not? Same variable. Both have x.
Different exponents.
Different exponents. Okay? They'd have to either both be squared or I'd have to get rid of that one. I think that pretty much covers it. Okay, so anytime you want to add or subtract, you have to have like terms. Multiplying, that's different. We don't get to that.
Yeah.
I don't even know if we get to that. Dividing, we do that, but we don't get to that much later. It's at the last.
So again, when you're combining like terms, you do nothing with the variables, nothing with the exponents. They're kind of like they're kind of in us to say, hey, the numbers that are with us, because we're the same, you can add the numbers together. You don't do anything with the variables. You don't multiply them; they stay exactly the same. The only thing that's going to change is the number that's attached, based on what signs each one has.
Okay, so when you have a number in front of a variable, you can call it that, a number in front of a variable, but there's a short word, one word, to say 7 is the, that's the
That's what
word.
a C.
Yep, Donovan?
Coefficient.
It's the coefficient. Okay, coefficient is just the number next to the letter. That's what it is. It's the number next to it, and we usually, where did we say we usually put the number? Do we put it before, or do we put it after?
Before.
We always put, yeah, we usually put it before. Yep. And then this is what Mr. Roy and I were just telling you. Only like terms can be added or subtracted. We already said that. You guys already have that written on your sheet?
Yeah, they do.
Yeah. Okay, so that's it for part 1. Okay, does anyone have any questions on terms, like terms, non-like terms? Okay, so we'll pass out part 2,
Yep.
and we'll take a look at that. All right, so we're going to take a look at part 2. again, this is just some basic background stuff. Like if we were using a book in this class, we wouldn't see this stuff in it because it's kind of stuff that you do beforehand, but we're just kind of refreshing your memory a little bit before we really get into the book stuff next week. So, we're going to try to figure out like what it means for a number to be greater than another number or less than. If you think about it on a number line, think about like left and right. Which way do the numbers get bigger? Are numbers bigger if you head to the right? Or are numbers bigger as you head to the left? Yeah, go ahead, Matt.
To the right.
To the right. So, if you want to know, wait a minute, is this number bigger or is this number smaller? Okay, well, if I mark that number and I mark that number, even if it's all blurred out and you can't see any of those, it doesn't even matter. Which number is bigger? We'll call it the red number or the black number. Even if you can't even see any of these, so we don't know. Should be able to tell just by where they are. Yep.
Red.
The red number. Okay, anything to the right is a bigger number. All right? So when you have the two arrows, we're going to fill in what we just said. If a number is to the left, it's smaller. If a number is to the left, it's smaller. If a number is to the right, it's larger. Okay, and you might be thinking, well, duh, yeah, that's easy. But sometimes it gets a little confusing when you start throwing in negatives, like -10 and +1. Like, oh, 10, right? -10, 10's bigger. No, not because it's negative, it's smaller. All right? So that just kind of will help you in your head. If you think about it on a number line, if it's to the right, it's larger. To the left, it's smaller. So, let's look at some examples and see if we can use one of these two symbols, either greater than or less than, to figure it out. So the first one, and I think you guys have to write these in, it says -5 blank -2. I want to know, is -5 greater than -2? Or is -5 less than -2? If you want to think of it on a number line, you don't have to make this number line. I'm just kind of showing you. Here's -5. Here's -2. So is -5 bigger or smaller? Yeah, Matt, right? Yeah.
Yeah, -5 is less than 2.
Absolutely. -5 is less than -2. It's to the left. It's smaller. Okay? That can get a little tricky with negatives.
And the further to the left it is, the less value it has.
4.5 and -6. Should I put a greater than or a less than? Yeah, right, Savannah? Yeah. It's a greater than. Perfect. Any positive number is always bigger than a negative. That one we don't even need to
Even
think
if it's a
about.
fraction,
Yeah.
it's just a half.
A positive number is always bigger than a negative number.
You know, like I said, it's a fraction, decimal, doesn't matter.
All right, so these are close. -5.3, -5.4. So if we had a number line, let's do like -6, -5, -4. Okay. -5.3, where is that? Is that to the left of -5 or is it to the right? Where's -5.3? Yeah?
It's like towards the front.
Towards which way?
Behind the key.
Would it be to the right of -5 to the left of -5?
It'd be to the left. So, towards the windows, right?
Yeah.
Okay. So -5.3 might be about right there. Now, how about -5.4? More to the left or a little more to the right? Yeah?
A little bit more to the left.
More to the left. Be about right there. Negative 5.4 is a little more to the left. So now, what symbol should I put in there? Is negative 5.3 bigger, or is it smaller? Yeah?
Bigger.
Bigger, absolutely. Negative 5.3 is a little bit, not much, but it's a little bit bigger than negative 5.4 because negative 5.3 is to the right. Okay, opposites. Yeah, I think you guys have this written. Numbers are opposites if they're the same distance from 0 on a number line. All right, so if I had something like this, okay, just watch me do this. What number did I just mark?
3.
Yep, I marked 3. What's the opposite of 3?
Negative 3.
Negative 3. Look at the distance. As long as I drew it kind of accurate, that's the distance from 0 to negative 3. And, well, it's not perfect, but that's the distance from 0 to positive 3. So they're the same distance from 0. So to show that a number is its opposite, that's where you just put a little dash in front of it. 3, negative 3. We put the little dash in front. Great, I think you guys know that. So let's look at this one. This says negative, negative, a half. Or if you want to read that negative as opposite, the opposite of negative 1/2. You could read it either way. So what happens when you have negative, negative, a half? This happens a lot with subtraction. You have two negatives next to each other, and I think we'll maybe see that later on. Yep, James.
Double negative equals a positive.
So what's that going to come out to?
A half.
Exactly. A half. Okay, the next one is the opposite of 0. This one's a little weird. It's the only one that actually does this. But what's the opposite of 0? What? Yeah, Ellie?
0?
It's 0. 0 is its own opposite. It's the only number that it's its own opposite. Now, C, we got to do something a little different. They want us to take the opposite, but they gave us a little work to do. So, what do I have to do first if I follow order of operations? What's the first thing? Najeli?
Well, you're gonna multiply the negative with the 7.8.
Okay, I see what you're saying. You're doing like a distributive property, pretending like it's a negative 1. You can do a distributive property. For this, let's stick with PEMDAS. All right?
So it's just 7.8 minus 3.2.
Yeah, let's do that first. Let's do what's in the parentheses. But I see what you are saying. So 7.8 minus 3.2. Okay, and you guys can always use a calculator for that. So we're going to get 4.6. But the answer isn't just 4.6. It's the opposite. That's what this symbol is. Opposite of 4.6. So what's the opposite of 4.6? Yusef? Negative 4.6. Negative 4.6. Okay, so now we'll talk about adding and subtracting positives, negatives, and then I think we'll get into multiplying so we keep all those rules straight.
All right. So a lot of times, Mr. Hager, Mr. Hager can say it as well. People might do like the steps. We'll give you guys like on notes steps to do a particular type of problem once we get going here, and you'll do all of the process correctly, but you'll make a mistake. We see a lot of mistakes with this, adding and subtracting positives and negatives. What we try to do every Monday when you guys come back from shop is we call it a basic arithmetic review. Like there's adding positives and negatives and multiplying positives and negatives, because we see all the time people make mistakes with this. when the signs are different, when the signs are the same, people have a hard time with it. Alright, so that's why we try to review it like once a week. To try to, again, at this point it's tough to kind of get those skills built up for you guys because you're freshmen now, but again, we try to catch you guys up if we can. So rules for adding and subtracting positives and negatives. So the first bullet there says same sign. So if you have, remember we're adding and subtracting now. You have numbers that have the same sign. Say if they're both positive or they're both negative. What's going to happen, Mary?
You add.
Yeah, you would add the numbers or combine the numbers, but what about the sign? Mary?
I would say the same.
Keep the sign. So if the sign's the same, combine the numbers together and keep the sign. That's the rule. That's the rule when you have the same sign. We would combine the numbers, or like Mary said, think of it as add and keep the sign. Again, so that's pretty easy. And a big thing when people have mistakes, what people don't see sometimes is very important. The sign to the left of the number, whether it's addition or subtraction, is married to that number. It's attached to it. It's with it. Alright? If there's no sign to the left of the number, what type of a number is it, David? There's no sign at all.
Positive.
Positive. It's just positive. This is the way it is. This is the way math is done. Right? There's no sign. We assume we know that it's positive. Alright? So if I had, I'm trying to squeeze it. Oh, never mind, it's right there. You guys, if you put combine and keep the sign, that's fine. You don't have to write this. I forgot that was below it. My fault. Right? If you have this, you're fine. Alright? So if I had something like, you don't have to write this down. 3 plus 5 minus 7. Paige, what type of number is 3? Positive or negative? Positive. Alright? Melanie, what about 5?
Positive.
How do you know?
Because there's a sign.
The plus, yeah, plus story. Hello, yeah. The sign to the left of it is positive. Alright? How about Ryan? What about 7? Positive or negative?
Negative.
Tell me why?
Minus.
Again, it may sound like, well, Mr. Roy, what are you making this? This is like stuff we learned in like elementary school. I've seen it 100 times. People still make mistakes with this. Alright? So the sign to the left belongs with it. No sign, alright? That means that it's positive. Now, if they have different signs, this is when it gets a little bit tricky. They have different signs, what's going to happen? If they're the same, combine them, take the sign of a larger number. What if they're different? Like if you had a negative 3 plus an 8. How would that work? How could I explain a rule for that? Alright?
You would take 3 away from 8.
Take 3 away from 8. Which number, if we ignored the signs, if we ignored the, oops, my God.
Just hit undo, Mr. Roy, I'll put it back. And again.
If we had this, if we ignored the signs, if we just ignored the signs at first and said 3 and 8, which one's bigger, the 8 or the 3? Donovan? 8. 8's bigger, right? So I'm going to get, when I do this, 5. What I do is I read it from the bigger. Once I've identified which number is bigger, then I think about the signs. All right? I take from the bigger one to the smaller one. A positive 8 minus a 3. Because doing a bigger positive minus a smaller negative is easier. All right? So the rule for this would be this. You're going to take the sign of the larger number in your answer. Again, make sure at first, ignore the signs. You want to take the sign of the larger number in your answer. 8 was positive, my answer is positive. If 8 was negative and 3 was positive, my answer would have been negative. So when you have 2 different signs, you always want to take the sign of the larger number.
Mr. Roy, should that say subtract and take the sign of the larger number to get the 5? Or like 8 minus 3?
We could put that. I think this for now, we'll leave it as that, Mr. Hager. So you want to take the sign. We can say like,
It just doesn't say how to combine the numbers, like we did up above with the add.
again, it all depends on, what the operation is. Is it subtraction? Is it addition? Again, so in this case, again, we subtracted the bigger from the smaller. And again, you can read it. I like to read it from the bigger number, subtracted from the smaller number. And then identify which one was bigger and pop the negative with it. Or leave it as positive. Alright? Everybody good with that? Okay. So now you got we're going to do 3 examples on the bottom. We got A, B, and C. You guys are going to have to write those examples in. Okay? So the directions are, it says perform the indicated operation. So I got a negative 12. We'll call this, we got same sign, different sign. So, Nathan, I'll let you finish writing down first. And again, it's okay if it's in parentheses. It's actually nice when it's like that, because it shows me it's kind of all, makes it look nice to know that it's negative. Kind of makes it like stand alone. So Nathan, do I have same sign or do I have different sign?
Same.
So what do I do?
Add on.
What's my answer gonna be? Positive or negative?
Positive.
Same sign says we'll add the numbers and keep the sign. So what's the sign?
Negative.
Negative, right? Then what am I gonna do to the numbers? Add them together, right? So I got 12 plus 19. What's 9 plus 2? 11. Then I'm going to carry the 1 over, right? So now I got 3 ones. I got 1 plus 1 plus 1. 31. So negative 31. What I do is put the sign first. I identify what the sign is going to be first. Then based on my rule, then I do my arithmetic. Let me say that again. I identify, all right, which one it is. If it's same sign or different sign. I identify if it's the same sign, great, I'll just keep the sign. If they're different, I'll identify which one's bigger and put that in I put my sign first. Then I'll do the math. Alright? And again, some of you guys might be able just to do this. Again, if you're not really comfortable with it, you want to use a calculator too. That's perfectly fine. Next. How about Bethany? Do I have same sign or do I have different sign? The different sign, right? Okay. So I'm going to ask you now, what sign will I take in my answer? Negative or positive? Why? Because 16, if I ignore the signs, 16 is bigger than 12. Now it is too, so I got my negative sign there, 16 minus 12, which is what? 4. Not 4.
I'm going to add what you just said. So he said to do minus. So when you have different signs, that's how you combine them. You subtract. Same sign, add.
Same sign, add, different sign, minus. Good point, Mr. Hager. So say it again, Bethany. 16 minus 12? 4. There you go. Sorry, Mr. Hager. I'll let you put that in. All right. So, like Bethany just said, we're going to put 4. We already identified what the sign was. Then we'll just do 16. Then we'll just do 16 minus 12. We'll go from the bigger number, then subtract from the smaller number. But you've got to make sure you put what your sign is first. If you don't put what your sign is first, then you'll make a mistake. Okay? And again, some of you guys might just know. I know 16 plus 12, or negative 16 plus 12 is negative 4. You just know. That's perfectly fine. That's good. It's not a bad thing. Good, Mr. Hager? Okay. One more. Now I got a couple different ones, right? So, we got a couple. Give me a pair that have the same sign? Give me a pair of numbers that have the same sign. Seamus, do you see a pair of numbers that have the same sign?
The 6 and the 2.
The 6 and the 2, they're both what?
Negative.
So what do I do?
You combine them.
Combine them. And what sign am I going to take?
The negative.
I'm going to take a negative, right? Same sign. Keep the sign. Add the numbers. Keep the sign. What do I get when I do that?
You get
Told me it's going to be negative. Huh? Say it again.
-8.
-8. I've already done. That's gone. That's gone. I like to cross them all so I don't get lost. All right. So I got -8 when I did the two negatives, right? What am I, Haley? What are my other two numbers that have the same sign? And tell me what the sign is.
8 and 4.
+8. I'll put these in a box. +8. +4. What do I do? Add them together, right? What sign will I get? Addition, right? They're both positive. Don't overthink it. They're both positive. Just like we did here. They were both negative. We kept the sign negative. They're both positive here. Keep the sign positive. 8 and 4 is 12. All right. Like terms, yes or no? Who says yes? Who says they like terms? Raise your hand. Who says they like terms? Raise your hand. Who says they like terms? Raise your hand. Hey, like terms or not? Who says? Catherine, is that a raise your hand or not? Not sure. I got T-Rex. I got T-Rex arms. All right. Who says they're not like terms? You say they're not like terms, Ellie? Tell me why.
Because
I think I know what you're thinking. Every once in a while I can read minds. Just don't tell my wife that, okay? Ellie, are you thinking this because the signs are different? They're not like terms? What are we looking for like terms? Someone tell me, raise their hand. Mary?
The same variable and same exponent.
Same variable. There's no variable here though. That's okay. They're both numbers. They're both regular numbers. That means they're like terms. If the signs are different, that's okay. But again, Ellie, I know what you're thinking. You're like, oh, well, then the sign's the same. That doesn't matter. But I'm sure other people are probably thinking that way too. You probably weren't alone. All right? So, Jake, which number is bigger? Again, ignore the signs. Which number is bigger, 12 or 8?
12.
12 is bigger than 8. I agree with you. 12 is bigger. So now I read from the bigger to the smaller. Do what the signs tell me to do. So I know my answer is going to be positive because 12 is bigger than 8. 12, Jake, 12 minus 8.
12 minus 8.
Yeah?
4?
4, correct. Good job, buddy. Here's our final answer, 4. Again, look and see, identify which one's bigger first. Write down the sign of the bigger. In this case, it was positive. All right? Sometimes it's negative. So the answer for that one was 4. Everybody with me so far? We got one page left, one back side, and then we are done review. All right, so we're almost there. We're almost done math for the week. Unless you have math lab. Sorry. Oh, Mr. Hager, what's that? All right. Okay. Whoa. Evaluate. Someone's gonna get me up to speed here. What's it mean? Someone raise their hand and tell me what that means. Anybody? Matt, what's up, man?
It's going to be like variables that mean numbers we're going to have to plug in.
Love it. Alright, so evaluate means, like Matt kind of said, we're gonna give you values for variables. We'll give you number values, and you plug them in for those values. That's all we're gonna do. You with me, Jake? Okay, good. That's Friday, man. We're almost there. Alright? So let's go down. So guys, on your guided notes, you don't have this written down. So I'll give you, 20 seconds so to get that written down. We have x plus y, 4, when x equals 5, and y equals -8. So as you're writing that, I want you to think how I would evaluate that, meaning how would I write that out, plugging in those numbers. Ellen?
5 plus -8 in parentheses.
Oh, I like that. Is there another way I could write it? Mary?
5 minus 8.
5 minus 8 works too. Because it's telling me it's negative 8. So I think of it as like, it's negative. This negative is going to overpower the positive that's there. So it'll be 5 minus 8. Both ways work. That's perfectly fine. All right? But again, don't think of this as multiplication. It's not. It's just isolating that negative number. So, do we have, Laurel, do we have same sign or different sign? Different signs, right? We got a positive 5 and a negative 8. So what do I have to ask myself? Which number is bigger? Which one, ignoring the signs, so which one's bigger, 8 or 5?
8.
8 is bigger. I agree. So the sign in my answer should be what? Negative. I'm going to write the negative. How do I read it now? When I do it in my head, how do I read it? Smaller to bigger, bigger to smaller. How should I read it? How should I read it? Smaller, the smaller number to the bigger number, or the bigger number to the smaller number? How about Dylan, what do you think? Read it from the 8 minus 5 or 5 minus 8?
5 minus 8.
Well, we already have the
No,
negative.
8 minus 5.
8 minus 5. I'm trying to have you guys. We're trying to have you guys identify the sign first. That way, when you write the negative sign down, if you put the negative sign or whatever the sign of the bigger number is, you're not going to really have to deal with negatives because you've already identified what it is. So we can just do 8. I already have the sign down here. 8 minus 5, which is what, Dylan?
3.
3. So again, identify the bigger number, all right, and then write down the sign it has, and just read from the bigger number to the smaller number. That's how you can solve. Or you can punch it in your calculator. That's fine too. All right. Example 5. So now we got a bunch. We'll do A first. So now, a little tricky here. What do we see here that we haven't seen yet in the example we did before, like example 4, and also the A, B, and C we did for example 3. What do we see here that's different?
There's a minus 1 and there's a negative number.
Double, right? What's that mean?
What did you do?
Keep, change. Whoa. What's that mean?
So that means you keep the 6, then you have to change the middle, and so it's plus.
Ah, okay. So it'll be like, we'll end up being 6 plus 9. Yeah. When I get the 2 negatives in a row, whenever you see 2 negatives in a row, that immediately becomes a positive. Right, immediately. All right? So now this becomes 6 plus 9. And like she just said, it would be 15. Again, same sign. A positive 6, a positive 9. Keep the sign positive and add the numbers together. It stays as a positive. All right, now I got a whole bunch here. We could do it like this. You know, I mean, one way I might do this is put parentheses to kind of split it up. Or, like we did in the one before this, I think it was example 3A, we kind of identified a pair of the same sign, one pair of numbers that have the same sign, and another pair of numbers that have the same sign.
Mr. Ray, I think for that one we should just probably follow PEMDAS.
Want to follow PEMDAS?
Go in order from left to right.
Okay.
Yeah, so don't put parentheses in, but just go in order left to right anytime you see addition and subtraction. Because if you put in parentheses, it could change.
So again, addition and subtraction hold equal weight, right? In PEMDAS? Everyone agree with that? Yes? Yeah? Good? Javier, yes? You agree with that? Miguel, I'm sorry. I like Javier. Miguel, you agree with that? Okay, cool. So, first thing I'm going to do is what? Ellie?
6 minus 9.
When I do that, what do I get?
A negative.
Excellent, because 9 is bigger than 6, so it's negative. And what's the number going to be?
Negative 3.
3, right? Because we put the negative, read from the bigger to the smaller. 9 minus 6 is 3. What am I going to do next? Yusuf, what am I going to do next? What am I going to do with that negative 3?
Leave it there and just do 4 minus 1.
No, let's go. It might help if I bring everything else down. So we're following PEMDAS, right? We only have addition and subtraction, so they both hold equal weight. So what can I do next? What's the next thing that's there? If I'm going left to right, it's negative 3. Negative 3 plus 4, which is? Careful. You're right, yes. Yeah. Again, 4 is bigger than 3. My answer has to be positive. Then this becomes 4 minus 3, which is 1. What do I need to bring down now? Savannah? Bring down the minus 1. Savannah, you might as well just finish it off for me. 1 minus 1? 0. Alright, so I'm going to add a few more steps. So we just follow the order of operations. The rules work. Same sign, keep the sign, add the numbers together. Different sign, you would subtract. Right? Identify which one has the larger number. That'll be the sign of your answer, and then subtract. Alright? What do we have here? Evaluate, we already talked about that. Matt already told me what that means. It means you're going to get some values for variables, plug them in. Alright?
That's a good one, yeah, to do.
You like that one, Mr. Hager?
Yeah.
Alright, good. I have
Something's gonna happen.
your blessing. Great. Alright, so this one. Someone tell me, Catherine, can you tell me the first thing I'm going to write? Okay, so again, that's the expression it's giving me, right? But it's giving me values for each variable. Do you see those values? So, the first thing written, look at what the first thing written is, and then look what it's telling us to evaluate for, or what we're going to plug in for that. So what's the first thing I'm going to write? Negative 7, perfect. I'm going to put that in parentheses, is that okay? Alright, so negative 7. Right there. Alright? Before I put a number, what's the next thing I should write? Before I put a number. Ellie?
The addition sign.
The addition sign. Very good. We don't want to skip that. Plus. Alright? How about... David, what am I going to write next?
8.
8, because y is 8. Good. What's the next thing I'm going to write before I write a number? Yusuf? The minus sign, because it's there, it's part of the problem. Alright? Finish off more. I like it. So Mr. Hager said, he's like, yeah, that's a good one to do, Mr. Roy. Why? He said, something's going to happen. He already told me what it is, man. I need something else. I like you, but... something besides Mary. Mary told me about this rule. Actually, no. Nigeli told me about this rule earlier. Mary's answered quite a few questions. Mr. Hager said something's going to happen. What is that something? Matt?
You gotta do like the keep.
Yeah, what'd you call it again, Nigeli?
Change.
Keep, change. Alright, so what's it going to become, Matt?
Plus positive.
Plus, I'm just going to put plus 9. Again, Nigeli, if you put 2 pluses in a row, if that works for you, that's perfectly fine. However you remember it, I'm fine with
I
it.
usually just put the number because it's already fun.
Okay, that's fine too. Alright? Everything else, I'm just going to bring down. Alright? So it'll be negative 7. I'm going to leave that in parentheses. Plus 8, I'm going to leave in parentheses. And again, we're doing PEMDAS. Alright? So what can I do first? Jillian, what can I do first? Again, I'm doing PEMDAS, so let's go left to right. Hey, Jillian, right?
Yeah.
I'm making sure I didn't screw your name.
The negative 7 plus 8.
Negative 7 plus 8. Different signs, correct? Which sign do I want to take in my answer?
Positive.
Why?
That's a bigger number.
Because 8 is against right alone. 8's bigger than 7, so I'm going to do 8 minus 7, which is 1. Perfect. What am I gonna bring over? I did this part. What am I gonna bring over? What haven't I done yet? The plus 9, right? 1 plus 9 is 10. Perfect. All right. Whoa, Mr. Hager. Whoa. He's skipping word problems. He's in a giving mood today. He's in a Labor Day mood. All right. I wish that was blank. Okay, that's okay. So here we just did our rules for adding and subtracting. Now some people think they make this mistake. We'll talk about that. I don't want to talk about that yet. We'll talk about that when we get to it. All right. So let's say, why don't we go up and bring this up a little bit? There we go. That's nice. Let me change the color. What I got? All right. So rules again. This works for multiplying or dividing positives and negatives. On your notes, you have it totally blank, right? Am I correct in saying that?
Yes.
So take a second, and I want you just to fill in these boxes. Fill in all 1, 2, 3. Fill in all 8 boxes right now with the signs, and then we'll go from there. Everybody's good. Everybody's all. I see some people already filled in the answers. Perfect. All right. Positive multiplied or divided by a negative would be what? Ellie?
Positive?
Positive multiplied divided by a negative.
Multiply?
We're multiplying or dividing. Works for both.
Yeah.
What would your answer be? What kind of a number? Positive or negative?
Well, if it depends on which one is bigger.
For this, it doesn't matter.
Okay.
It's only when you're adding and subtracting that we care about the bigger or the smaller.
So would it be negative?
Exactly.
Alright.
Again, for multiplying and dividing, it doesn't matter what number is bigger. It does not matter. Alright? If it's a positive, multiplied or divided by a negative, your answer is going to be negative. So it's tough, but get that bigger, smaller rule out of your head. It only works for adding and subtracting. Alright? Next, we just have the opposite. We have a negative multiplied and divided by a positive. Chris? What will my answer? What type of a number? Positive or negative?
Negative.
Negative. It's the same thing as this, just written in opposite order. So it's going to be negative. Alright. Yusuf's going to tell me. Negative multiplied and divided by a negative. Positive. Again, this is where people make mistakes. They think that when they do this, sometimes with like adding and subtracting, they want to make the number negative. No. Alright? If you're multiplying and dividing, it becomes positive. When you're adding and subtracting, if the signs are the same, keep the sign. Alright? Now we get a positive, positive. Alright? Savannah? Positive. It's not negative. It doesn't work that way. Alright? Positive times a positive is a positive. Alright? So now we'll do a couple with multiplication. Alright? So this one has 2 steps. Alright? We got some division and we have some multiplication. So we got a positive 8 divided by 4 times 20. How about Miguel? 8 divided by 4? 2. I'll bring down the times 20. Miguel, do you know 20 times 2? 40. That was easy. The signs were all the same. So, again, everything was positive. It's going to stay positive. Alright? Now, I see mistakes at the calculator all ready to roll, and we will use it. Alright? But, I need someone to tell me, for this one, I got negative 6.8 times negative 5. Donovan, what are you going to tell me?
It's positive.
It's going to be a positive number, right? Know your rules. Negative times a negative is a positive. Mr. Hager's going to do it on the calculator. Like Donovan told us, it's going to be positive because they're both negative. Negative times a negative is a positive. Positive 34. Alright? Now we had a mix here. Alright. Negative 15 divided by a negative 5. I've been thinking of something different, please, but thank you. How about Alejandro? You go by Alex. Or Alex, right? Okay. Alex, so negative 15 divided by negative 5. Positive or negative? Positive, because they're both negative, it becomes a positive. Positive what? What number? 3. You got it. Let's tell you, you don't want to do that one?
Sorry.
It's up to you, I don't care. You can skip it. Oh, he's blocking it out.
Oh, yeah, we can do it.
Now, I got a negative 27. When we have something like this, guys, sometimes it might look like this. It's kind of like in the middle. And it's kind of like in the middle like that. We just assume that it goes with the top number. All right? So I got negative 27 divided by a positive 3. Positive or negative? Chris?
Positive. Wait, no, negative.
Negative, right? So the answer's going to be negative. What number, Chris?
9.
9. Very nice. Good. All right. Now we got special cases. Oh, man. All right. So this is, again, this is when like we're dividing something by 0. All right. So you guys probably know this. So if we have 0 divided by a number. So if I had like, you don't have to write this down. 0 divided by negative 1,207. It doesn't matter. Your answer is going to be 0. So if 0 is on the top, and there's a number on the, whatever number is on the bottom, I don't care how big it is, how small it is, whatever it is, your answer is going to be 0. I don't care if it has you doing a bunch of like math on the bottom. You might be doing like 0 over 4 times 2 plus 5. Doesn't matter. Your answer is still going to be 0. All right? This figure is kind of showing you some examples on the calculator. You did 0 divided by 8, 0 divided by 746, 0 divided by negative 25.7. They're all going to be 0. All right? Now, we get a number on the top. So let's say we had, so you can do 0 divided by 9. When he hits enter, when he hits equals, what's the calculator going to say?
0.
Savannah? Let's see. It says error, right? Can't do it. So if we scroll, you said undefined, right, Savannah? Right. Undefined. Mr. Hager actually taught me this trick when I first started with him 5 years ago. All right? N for number, 0 on the top, on the bottom, I should say. N-O. It's not possible. No. Number on the top, 0 on the bottom, no, it doesn't work. It's undefined, like Savannah told us. All right? Last example we have, all right, is if we did 0 divided by 0, it says undefined. All right? Same thing would happen. You guys had all that stuff on your notes anyways. All right? Now, Mr. Hager kind of just showed you guys, if we have, say I'm evaluating for A, I had 1, for B, I had 3. I flip it. I put B, our B in this case that we plugged in for was 3. All right, so I want to put it on the top now. On the bottom, I'm going to put A, which we plugged in as 1. So it's just, all I'm doing is flipping the fraction. I'm taking the bottom, putting it on the top, taking the top, putting it on the bottom. What's the fancy word for that? The jelly? Reciprocal. Did you see it up there?
No.
You didn't know. Not lying, man. Okay, good. Alright, so reciprocal. We get into some of that stuff when we talk about slope and things like that, but it's still a good term to know. Again, like we talked about, exchange the numerator. That's the fancy word for the top number numerator, denominator, bottom number. Just flip them. That's all you're going to do. Okay. To divide two fractions.
Is that already on your notes?
Yeah, you guys already have this. Keep the top fraction the same and multiply the reciprocal of the bottom fraction. All right. So what that means is 8 over 9 times, I'm still keeping the negative. I'm flipping the fraction. It didn't say the opposite. It just said reciprocal. That means flip it. But I'm still going to keep the negative sign. Now, I'm sure some people out there right now are like, oh my God, like it's a fraction. Not a fraction, I can't handle it. I can't do it on a Friday. You can do it. Right, you can do it. Again, we can multiply. There's two ways you can do this. Somebody want to tell me one way that we can do it, Matt?
Yeah, you simplify it first. So you do.
You could cross cancel it, right? So you're saying, before I even get to that, Matt, that's perfect. Is my answer going to be positive or negative?
Positive.
I got a positive 8 over 9 times a negative 3 over 2. So a positive times a negative.
Divide.
Huh? Or divide, I'm sorry, we're dividing.
Oh, so it's going to be negative.
Negative.
Yeah.
Alright? Now, like Matt said, we can just cross cancel. Alright, he's saying, okay, make the 2, because 2 divide, again, 2 goes into 8, right? So 2 goes into 2 one time. 2 goes into 8 how many times, Matt?
4.
4. That cancels out. I know 3 goes into 9, right? Ellie, what are you going to say?
3 goes into 9 3 times.
So, what do I do?
Cross it out and put a 3 there.
What about up here?
1.
I got 1. When I get to that point, Matt, what can I do?
You can multiply.
Multiply straight across. 4 times, we're already at the negative sign, so that doesn't matter. 4 times 1, 4. 3 times 1, 3. Right? Or I'm not going to do, for the sake of time, guys, you could have this done 8 times 3, and then 9 times 2, and then you could have reduced. Either way works. It doesn't matter. We don't care which way you do it, as long as you get it simplified. Alright? We got some combined like terms here. You know what, guys? For these last 2, why don't you do them on your own? Just for the sake of time. You've heard us talk enough. Right? Just usually at the end of the lesson, guys, we have some quick reminders. We just don't have it on there today. But again, make sure if you haven't your paperwork turned in for Mr. Hager and I, the class rules, get those signed, get them in by next week. Sign up for Google Classroom if you want to go on and check out Math with Hager. All right? Today's lesson will be up very soon. Yesterday's lesson's already up.
Mr. Roy, do they need to copy the 4 problems down?
Yeah, you can copy. I don't care if you copy them down or just do them and just write your answer. I don't care. We only got like 3 minutes left of class.
Are they already on their notes though?
They're not on their notes. No mistake. They're not. So again, binder, get your paperwork signed, sign up for Google Classroom. Also, check out Math with Google. All right. Next week we'll start our first week of actual new stuff. Next week will be a 5-day week. It'll be a normal week. We'll have a test next academic Friday. I'm sorry. This is the way it is. You will have a reference sheet for it though. Don't panic. All right.